Hello, Legacy Savers. So today you're looking at graphing absolute value functions. This is the second day of transformations, or the second video. This is the actual examples video. You're going to want the writing utensil, something to write with, and then the foldable with the various rules about transformations. So, first example we're going to do, you definitely want to write this down. I know don't have my pencil in the right hand corner, but definitely write this down. Okay, so right over here, right. Okay, so we're gonna need to look. We're gonna describe all of our transformations and then basically graph it, and then do all of our key features of the graph. So first thing, it looks like from my foldable here, I'm looking, a negative in the front means we're reflecting over x-axis, right? This 2 right here means we're vertically stretching. Vertical stretch by 2. Looks like we're moving right 3 and down 1, right, from this. Okay, so here's how you're going to want to accomplish the task of figuring out what the graph now looks like. You're going to want to refer back to the parent table of graphing absolute value functions. Now you're probably saying, where did I get that? Well, the absolute value parent function, if you remember when we graphed absolute values with tables, you wrote down all of the information about the parent function of absolute value. So in this case, we actually have that parent table. -2, -1, 0, 1, and 2. And then it was 2, 1, 0, 1, 2, right? Because if I plug into y equals the absolute value of x, that's what we're going to get. Now, here's what we got to do. We got to change this table to do what we need it to do. So now we gotta decide, what do we do first? So in order of kind of the order of operations, if you want to call it that, of transformations. First thing you're going to want to do is you're going to want to complete any left-right movement. So check your left and right movement, your horizontal shifts, if you want to call it that. Then you're going to take care of stretching / compressing. Okay, so take care of him next. Then we're going to take care of any reflection. That's done. And then finally, you're going to take care of your up and down. Think of it this way. You got to start at the inside, because this is the inside of the parentheses, in this case vertical bars. This is the multiplication, still the multiplication, and then this is the outside of the vertical bars, adding subtraction. Okay? So, left and right. We said we're moving right 3, so I gotta think about it. How does that affect my parent table? Well, if I'm moving right 3, it adds 3, right, to all of my x values. So I'm going to add 3 to each of these x values. Okay. Then I gotta stretch, compress, and we said we're vertically stretching by a factor of 2. Well, vertically stretching, vertically tells me it's for the y's, right? If it's vertical, it's up and down. And if we're by a factor of 2, that tells me we're going to multiply each of these y's by a factor of 2. So each one of my y values should become 2 times bigger. So at a corresponding x value, instead of getting up to 1, I should get up to 2 instead. Now taking care of the reflection. If I reflect over the x-axis, what is that going to do to your x? It's going to change your y's to negative, right? Because if I reflect over a y-axis, basically I'm going to make everything negative. So let's go ahead and change these guys to negative there. And then finally, down 1, which is just going to subtract 1 from every single one of our y's, right? Now, looks very messy, but let's go ahead and figure out what our new final table is. So x, y, didn't leave a whole lot of room for myself. Negative 2 plus 3, that's 1, 2, 3, 4, and 5. What a coink dink. Negative 4 minus 1, that's negative 5. Negative 2 minus 1, that's negative 3. Negative 0 times 2 is 0. Minus 1 is negative 1. Negative 2, negative 3, and then this guy should be also negative 5. So that this table right here, this is that guy's table. So let's go ahead and graph it. So 1, negative 5, 2, negative 3, 3, negative 1, 4, negative 3, and 5, negative 5. There we go. Whee! Oh, that was terrible. Now, as you can see, guys, that factor of 2, vertical stretch. Notice normally it would have been 1, 1, right? Well, now it went, for every time I went right or left 1, instead of going up 1, I went up 2, or in this case down 2 because we had that reflection. Yes, that does basically, it is acting like a slope, but be very careful not calling it that, because future functions we're going to graph, that is not what it's going to do. But you will see on this particular graph, yes, it is basically the slope of what those lines are. Vertex, he ended up to be right in the middle here. He is 3, negative 1. This guy is a neither. He is definitely not even because he doesn't fold along the y, and he definitely doesn't have symmetry about the origin. He is bounded above, right? Because if I look here, he only can get so tall. He can't cross over a particular y value above him. He has a couple, only one intercept, it looks like. Looks like it's at negative 7. So 0, negative 7 would be one of my intercepts. No x-intercepts. We are definitely continuous. Increasing intervals. So increasing intervals, remember, that tells you how far up can you go, or where on my graph does it look like the graph from left to right is going up, which it looks like from here until I hit right here, right? Right there is where I'm stop increasing, which would be from, well, starting at negative infinity, right? To 3 is when we stop increasing. Decreasing, well, I start decreasing, lost my pen there, going down, right? We start right here and then go forever down that in the right direction. So got 3 to infinity for my decreasing interval. Minimum, my absolute minimum is negative infinity, but any local minimums, I got none of them. Okay, absolute and local maximum is located at y equals negative 1 at x equals 3. Basically the vertex, if you want to consider it that. Domain, so how far left did this graph get? Well, it's going to go forever to the left, right? So that's going to be negative infinity. How forever to, and then forever to the right as well. So that'd be to infinity as well. Range, well, it's going to start bottom to top. It's going forever in the negative direction, but it only gets up to negative 1. Can't go past that. Okay, so now they're going to ask us to write the equation as described. So if I look at this thing, we got parent function of y equals absolute value of x reflected across the x-axis, compressed vertically by a factor of 3/4, and then shifted right 5 units. So how do I figure out what this is actually? Well, I gotta kind of put the pieces together. First thing, I'm gonna change from orange. Kind of hard to read. There we go, blue. We're gonna go f of x, right? I know it's gonna be absolute value x. Now, I notice it's reflected across the x-axis. That tells me there's a big fat negative sitting in the front there. Compressed vertically by a factor of 3/4. So that tells me, because our vertical compressions and stretches are outside, right? So there's going to tell me there's a big 3/4 right there. It's an absolute value function. Right here it tells me that. And I shifted right 5 units. Well, there's always an x in here. And left and right is always in the box, right? Or in the absolute value bars. Well, and if I went right, it's opposite. So that means it's going to be a -5 in there, correct? Now notice it didn't say up or down at all, so literally there can be +0 back here if you want to put that there. I'm not going to. Now, we're not going to graph it, but what if we would have to graph this? So what I would do is, whoops, gotta write my parent table correct. Jeez, Marsh. Figure out my parent table, like that. Then I would complete our steps. So remember, we go right 5 units. That means I'm going to add 5 to everybody. Okay. Multiply everybody by 3/4. And then tack a negative onto everybody because of reflection. And then I would figure that out, and then I would be able to graph that. It'd be disgusting, but it would work. I would get definitely a good graph. Okay, and then looking how to write the equation of the function. So I got a graph here. Well, I know it's going to start with a y, right? So first thing I like to do is write out what transformations happened. Well, it is a flipped v, right? It's a reflected v, so I know definitely we reflected this guy in x-axis, because that's what made him flip like that. He went, because normally they'd be at 0, 0, so it looks like he went right 1, then it looks like he went up 3, right? And then normally, if this didn't have a stretch or compression, it would have been 1, 1, right? For every time I went right 1, I would go down 1 in this case. This guy, it went down 2. So this tells me this guy has been stretched by 2, a vertical stretch by 2. Okay, so for every time I moved right 1, my vertical has been increased by 2, a factor of 2. So let's start writing here my equation. What's been reflected, so that tells me there's a big giant negative sitting out here. Next part you want to figure out is if you have a vertical stretch, which we do, we said it was 2. Absolute value bars, I went right 1, so that means usually there's a negative in there, right? -1, because that would be right 1. And then finally up 3 for my final question. And that's the end of this video. See you later, Sabers.